In this video, we're going to talk about something called the order of operations. An operation is basically something that takes two values in and it'll combine them in some way and then spit out a result, an output. So for instance, addition is an operation. If you took 3 plus 2, it would combine them and it would give you 5, and that's a new answer. But there's something we forget a lot of times about operations, and that's the fact that they can only accept two numbers at a time. And so things get a little confusing if you have more than one term in your expression. For instance, if you had 3 times 4 minus 2, this could mean two different answers depending on what order you applied these operations. If you did the multiplication first and did 3 times 4 and then subtracted 2, you'd get a different answer than if you did 4 minus 2 and then multiplied by 3. So one way we could eliminate this confusion is by using parentheses very heavily. If we applied parentheses would group two of the numbers together to be done first, and then we would apply the other operation afterwards. So for instance, if you said parentheses 3 times 4 and then subtract 2, this would be very clear to somebody reading your work that you obviously mean 12 minus 2, which would give you 10 as an answer. But if you meant 3 times parentheses 4 minus 2, then this would mean 3 times 6, because 4 minus 2 gives you, 3 times 2 rather, 4 minus 2 is 2, and 3 times 2 would give you 6, which is a different answer. And so you say, well, that clears it up then. I guess we'll just use parentheses all over the place. But see, that's not very practical though. It's a good idea, but when you start getting larger expressions like this that have many operations, then if you try to go with the parentheses only way of doing things, you would have literally 7 or 8 different sets of parentheses telling you what order to do these operations, which can only accept 2 inputs at a time. And so this is what the order of operations is going to help with. It's going to help us reduce how many parentheses we have all over the place, because it's going to tell us the order, the usual order or the default order in which operations are typically completed. Okay, so here's the order in which things are done. If you see parentheses takes precedence over everything. So if you see parentheses, that's done regardless, first of all. But then after that, we'll have exponents that are done first, then multiplication and division, and then addition and subtraction. And the reason I have these 4 highlighted is I actually have a separate little comment to make about these. Just because multiplication is listed before division and addition is listed before subtraction, that doesn't mean that multiplication takes precedence over division or addition takes precedence over subtraction. See, these last 4 we have to be careful. Multiplication and division are actually on the same level, and so are addition and subtraction. So if you see only these operations available, we'll simply do them from left to right. And that's the case with both of these guys. And so this again helps us eliminate how many parentheses we have. So for instance, if we had 10 minus 3 times 2, there's no more ambiguity. I don't have to clarify whether I mean 10 minus 3 times 2 or if I mean 10 minus 3 times 2. If there are no parentheses listed and there are no exponents, then multiplication takes precedence over subtraction. So I would combine the 3 and the 2 first to give us 6, and then we'll do 10 minus 6, which is 4. Okay, and this is consistent for whoever works the problem. If everybody follows the order of operations, that'll really cut down on how many parentheses we have to write all over the place, because everybody understands that we're going to do the operations in this order unless specified differently by parentheses. Okay. Now, how do you remember the order of operations? Because it's, you've got exponents and subtraction and division, and it's easy to forget what order these are supposed to come in. So most people, when they teach order of operations, use kind of a juvenile type of mnemonic device. It's a little silly, but it works really well, and a lot of people use it. It's a sentence that says, "Please excuse my dear Aunt Sally," where the leading letters tell you all you need to know. Parentheses, exponents, multiplication, division, addition, subtraction. So just remember the sentence, "Please excuse my dear Aunt Sally," and you'll be able to remember the order of operations. All right, let's close out with a couple quick examples. If you had 3 times 4 minus 2, because we know "please excuse my dear Aunt Sally," then I know that multiplication, this operation, takes precedence over subtraction, which is this operation. And so the order, the kind of the default order, the understood order that these operations should be done would be to do 3 times 4 first, which is 12. Then we'll subtract 2 from 12 and get 10. So that would be our answer. But these become especially helpful for really big operations like this. Here we have 7 plus 5 divided by 4 minus 3 times 9 plus 1 plus 7. This could be interpreted, if we didn't have order of operations, a dozen different ways. And so before order of operations, somebody would have to literally group this, literally, every which way, just so everything is clear what order we're supposed to be doing these in pairwise, or two numbers at a time. And so we don't want to have that many parentheses. So if we know "please excuse my dear Aunt Sally," then I'm going to do all the parentheses first, which there's a parentheses here, which is 9 plus 1. And even though it's not listed, there's actually a parentheses here as well. Any numerator or denominator is its own set of parentheses. And the reason that is when you see division, what would you divide 4 by, or 4 into? What would we divide by 4? I don't know, it's 7 plus 5, whatever that is. And so obviously we would have to figure out what 7 plus 5 is before we could divide it by 4. And so there's an understood grouping in any numerator or denominator. So step 1 would be to say 12 divided by 4 minus 3 times 9 plus 1 makes 10, and then minus 7. Okay, so parentheses are done. There are no exponents. Next we'll do multiplication, division, and they're on the same level. So we'll do them all at the same time. So 12 divided by 4 is 3. 3 times 10 makes 30. And we still have minus 7 on the end, but I'm not doing the subtraction yet. Oh, I'm sorry, and this is addition. That was a typo, my mistake there. That should be a plus. 3 times 10 plus 7, just a typo. All right, and then lastly, we have addition and subtraction. Now, here's where you also have to be careful. Somebody might misunderstand me and say, "Oh, well, addition comes before subtraction, so I better combine these first." That's not the case. If you look back at what I said earlier, addition and subtraction are on the same level. So these operations are done from left to right if that's all you have. Okay, so addition does not take precedence over subtraction. So we'll do 3 minus 30, that's negative 27, and negative 27 plus 7 makes negative 20. So anyways, you see how helpful, how extremely helpful order of operations can be, because they limit how ugly our expressions are looking because of eliminating the need for tons and tons of parentheses all over the place.